Welcome to solverfy.
Right. When we look at bond angles for our carbon-hydrogen compounds, we have to consider the actual geometry of each molecule to figure out what kind of bond angles we'll see when we look at some typical molecules. Now, for a 60-degree angle, that's a pretty small bond angle when we look at most structures, so there aren't too many examples of this. Something like a 60-degree angle might be something like a cyclic compound that has 3 carbons. So if we look at it in the notation where we have the line structure, it's really just going to look, whoop, those should be straight. It's just going to look almost like a triangle. Okay, so it has a carbon at each intersection of the lines with the appropriate hydrogens attached. All right, so that would be our 60-degree angle, right? And we're looking at the angle in between, between each bond here for those carbons. Okay, so it is a pretty tight angle there, so it doesn't happen very much. Right, when we increase it slightly, if we look at something like 90, okay, another cyclic compound, so our 4-carbon compound, cyclobutane would be an example. Okay, so if those are all connected and equally spaced, it does look kind of like a square. Okay, and remember each intersection is a carbon and will have the appropriate hydrogens attached to it. That would be a 90-degree bond angle. Okay. All right, when we get to that 109.5, that's when we start to see a lot more common organic or carbon compounds. So something like, oh, come on, oh, hang on, okay, ignore that. When we get to something like CH4, right, so CH4, it's a tetrahedral compound, carbon with 4 hydrogens attached to it. Okay, we can't really draw it very well in that line structure because it is just a carbon, so it would literally just be a dot. Okay, that tetrahedral structure always has an approximate bond angle of 109.5. Okay, so that's a very common one. You'll see that with a lot of alkanes, right, our single bonded carbons. Okay, so that's very common. Right, the other two we're going to look at are 120 and 180. Right, so for 120, that's our trigonal planar shape, so it's a 3-point structure. Right, so if we look at something like this double bonded carbon structure, okay, this would be ethene because it has a double bond. Okay, when we look at the bond angle of one carbon, it doesn't matter which carbon because they are the same, right? We see that it has three things attached to it, right? It has the 2 hydrogens and then the other double bonded carbon, which gives it that 120-degree bond angle. Okay, so we can look at this bond angle as 120, right? Or we can consider this bond angle or this one, right? And they're going to be the same. They're all about the same, all about 120. Right. Finally, we have 180. Our 180 is going to be our linear structure. So you'll see 180 a lot when you find triple bond carbon compounds, because that bond angle right here, it's linear, right? So that's our 180-degree bond angle. Okay. Also, it happens to be over here as well, right? Because we have a symmetrical molecule. Okay, so we're looking at that linear structure, right? So we will see that the bond type, right, and the number of things attached to the carbon will determine the bond angle.